Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll review what was covered in week 7. So we covered 3 things: transformations of graphs, hyperbole, and circles. So let's start by transformations of graph. So if we take the graph of fx, if we add something in the brackets, it shifts the graph left or right. But this sort of goes in the opposite way that you'd expect. If the number in the brackets is positive, we go left, and negative, we go right. That's a bit counterintuitive because positive numbers are to the right. You'd think if b was positive, you'd go right. But make sure you don't make that mistake. If this number in the bracket here is positive, you go left, negative, you go right. So if we add a constant to a polynomial, it has the effect of shifting the graph up or down. And this does work the way you'd expect. So if you add a constant to the polynomial, it goes up, and if you subtract a constant, it goes down. So the last two are just reflections. If you replace all the x's with a minus x in the function, it reflects it about the y-axis. And if you put a negative out the front of a function, that means you change the sign of each of its terms. That's a reflection about the x-axis. So let's look at an example here. So I've just got some random graph of fx, and I'm going to draw the graph of f of x minus 2 minus 1. So these two things here tell us what we do. What we're going to do is we're going to shift each point of this graph 2 to the right, because if b is negative, we go right. We're shifting it 2 to the right, and 1 down because k is negative. So, of course, we can't shift every single point here. We can't draw that. That would take forever. So what we're going to look at is distinctive points. So, for example, this x-intercept here. We're going to shift it 2 units to the right and 1 unit down. So this turning point here, we're going to shift it 2 units to the right and 1 unit down. So this point here, where it turns from a curve to a line, we're going to shift it 2 to the right and 1 down. So when you've done enough of these points, you can just join it up. So it's going to look like this. It's going to go up, it's going to hit its turning point, stop, turn around, go down here, then it turns into a straight line like that. So in black is the graph of f of x minus 2 minus 1. That's how we transform graphs. All right, let's now look at some hyperbole. So hyperbole are these weird looking graphs like here that are in 2 pieces. So hyperbole have asymptotes, unlike polynomials, which never have asymptotes. So asymptotes are like no-go zones. So if the function is of this form, the graph will be a hyperbola, and it will have 2 asymptotes. It will have a vertical asymptote at x equals minus b, a horizontal one at y equals k. So why is that? Why are there no-go zones for this graph but not for polynomials? Well, the thing is because we're dividing here. And now you can't divide by 0. If x was minus b, if x was equal to the negative of whatever this number is, you'd be going a divides 0, which you can't do. So that's why there's an asymptote at x equals minus b. Now, if you have a fraction and the top is not equal to 0, the whole fraction can't equal 0. So y cannot equal 0 plus k. That's why there is an asymptote at y equals k. So when you're graphing a hyperbola like this, you need to first mark its asymptotes, and then you need to look at the a value to determine its orientation. If a is positive, if this number on top of the fraction is positive, then the hyperbola lives in the top right and bottom left. If a is less than 0, or this number on top of the fraction is negative, it lives in the top left and bottom right. Because these asymptotes kind of divide the plane into 4 quadrants. So that's what I mean. If a is negative, it lives in the top left quadrant and the bottom right quadrant. So let's have a go at graphing this one here. So our first step would be to mark the asymptotes. So here, b is minus 1. So the asymptote is minus 1, or x equals 1. The asymptote here is at x equals 1 because if I substitute x equals 1 here, I get 1 divided by 0, which I can't have. So this whole fraction cannot equal 0. So y cannot equal 0 plus 2, which is 2. The horizontal asymptote here is y equals 2. So I'm going to draw that in. So y equals 2 here, k value is 2. That's why that's the asymptote. Now, because this number here is positive, a is 1, it's going to live in the top right, bottom left. See, the asymptotes have split it into quadrants. It's going to live in the top right and bottom left. So it's going to be up here and here. But we sort of don't know, do I draw it over here and over here, or is it a bit closer? So to do that, I'm just going to find a point in each quadrant to mark through which the hyperbola passes. So here, if x equals 0, I get -1 plus 2 is 1. This passes through the point 0, 1. So marking that point, the y-intercept, helps me know that it's going to go like this. Hyperbolas all have the same shape. They get closer and closer to their asymptotes, but they never actually touch the asymptotes. So similarly, if x was 2, I'd get 1 over 1 plus 2, which is 3. This passes through the point 2, 3 there, which helps me know that it's going to go like this. So the shape of hyperbolas is pretty much always the same. It's just where are the asymptotes and in which quadrants they go through. So let's have a look at now finding the equation of a hyperbola when we're given the graph. So this is how you find the equation of a hyperbola when you're given the graph. Now, we know that the equation of any hyperbola is going to be of the form y equals a over x plus b plus k. So b and k are easy to figure out. You just get them from the asymptotes. So this one has a vertical asymptote at x equals -2. So b is -2. It's going to be +2. And that makes sense, because if x equals -2, then this would equal 0, and you can't divide a or any number by 0. So k is really easy. The horizontal asymptote is -3, so k is just -3. So the last thing we need to find is a. So that's not as easy to find. What we need to do is we need to substitute a point, an x and a y value into this equation and solve for a. So just pick a point that is easy to see. So for example here, the point 0, -4 is easy to see. So substituting y for -4 and x for 0, I get this equation here that I'm going to solve. So first I'm going to add 3 to both sides, and then I'm going to times each side by 2. I get a is -2. And it makes sense. We should expect that a is negative because this hyperbola lives in the top left and bottom right. So now that we've found all of the numbers, we're done. The equation of this will be y equals -2 over x plus 2 minus 3. All right, let's now have a look at circles. So if you have an equation of this form, x plus a squared, y plus b squared equals r squared, it is a circle. Its center is -a, -b. So the x coordinate of the center is the negative of this. The y coordinate of the center is the negative of this. And the radius is r. The radius is the square root of this. So here we have a circle. We're going to find out what its equation would be. So its center here is marked at -3, 2. So that means the equation would be x plus 3 squared plus y minus 2 squared, because the coordinates of the center are the negatives of what go in the brackets. So here the x coordinate was -3, so +3 goes in the brackets. Here the y coordinate of the center was +2, so a -2 goes in the brackets. So now all we need to do is find the radius. Well, of course, the radius is just the distance from the center to the edge of the circle. So here the radius is 4. We go 4 in each direction from the center. So we go 4 to go from -3 to -7, 4 down to go from 2 to -2, 4 up to go from 2 to 6, 4 to the right to go from -3 to 1. So because the radius is 4, the number that goes here at the end is not 4, it's 4 squared, which is 16. So if you were to graph this circle here, you'd end up with this graph here. All right, we just need to look at one more example involving circles. This is a question many find challenging. So, we're going to find the radius and center of this circle here. So, a lot of people would look at this and say, this doesn't look like a circle, because the equation of the circle is this form. So, to find the radius and center, we're going to need to take this and make it look like this. So, the way we do that is by completing the square. I need to somehow turn this into a perfect square, because I've got a perfect square up here, and turn this into a perfect square, because I've got a perfect square up there. So hopefully remember when we were doing parabolas, for perfect squares, I do b over 2 and then square it. So 6 divided by 2 is 3. Square it, you get 9. I need to add a 9 here, so this is a perfect square. So I need to do the same for y's. So negative 10 divided 2 is negative 5. Negative 5 squared is positive 25. So I need to add a 25 here so that this is now a perfect square. And just remember, whenever you square a negative, like negative 5, you always get a positive. So this is a perfect square and this is a perfect square. But I can't just add 9 and 25 wherever I please. That would change the equation. So what I'm going to do, because I added 9 and 25 to the left-hand side, I'm going to need to add 9 and 25 to the right-hand side. So this here is x plus 3 squared. I know it's x plus 3 because 3 is half of 6. The number that goes in the brackets being squared is b over 2, or the coefficient of x divided by 2. And it's the same for the y's. It would be y, and the number that goes in the brackets is minus 10 over 2, which is minus 5. So this here is x plus 3 squared. This here is y minus 5 squared. And on the right-hand side, 15 plus 9 plus 25 is 49. Now, this is in the right form of a circle. We can find the center and radius easy. So the center is a point, and its x-coordinate is the negative of what's in the x bracket, so negative 3. And the y-coordinate is the negative of what's in the y bracket, so positive 5. So minus 3, 5 is the center, and the radius is just the square root of this here. This is r squared, so the radius would be square root of 49, or 7. All right, thank you so much for tuning in, and sorry about the long video. You're doing a great job. Keep your head up. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.